All right, guys, so here we go, example number 3. We have a function here and an interval from 2 to 5. So I've done just a quick picture of it. You don't have to do the picture to do the question, just trying to do that to help us understand what's happening here. So for example, if you put 2 into that function, 2 cubed is 8 plus 5 is 10. So 2 would plot with 10. 5 cubed is 125 plus 2 is 127. That scale is all jacked up. The picture isn't perfect. Okay, I get it. But here's the idea. They're saying, what's the average value of that function? And I want to point out that the function would be that vertical axis, right? So for example, 2 has a value of 10, 5 has a value of 127. This could oscillate in between. But anyway, the idea would be, what would be the average of every functional value between 2 and 5? All of them. How many are there? Infinite. Okay? So the idea would be, the analogy here would be, if you want the average of all the values of the function, wouldn't you want to add up every functional value and then divide by the width of the interval? I spoke quickly about that. This will be on the screen. It's in your notes that we gave you. But the point would be, if you want to add up every functional value from 2 to 5 so that you can average them, wouldn't you integrate that function from 2 to 5? So if we integrate that function from 2 to 5, that would be the same thing as essentially putting every number between 2 and 5 into that function and getting all these functional values and then adding up every single one of them. That's the idea. That's what an integral does. I want to remind you, it's an infinite sum. Remember, we talked about the fact that a definite integral is an infinite sum for every value of that function over that interval. Okay, so that, you're like, well, how's this change then? But there's one more thing that we want to do. If we want to find the average for every value over that interval, not only do we add them all up, but then we do, as I said, you divide by the width of the interval. So one more step here, basically. We're going to say, okay, we're going to add up every functional value between 2 and 5. That's what our friend the integral does. And then we'll divide by the width of the interval. 5 minus 2 in this case. B minus A. That's it. So you do your definite integral, and then you divide by the width of the interval. I think it's fair for me at this point to just tell you what would happen beyond that. So again, on the numerator part of this, you would do the mechanical, find your antiderivative, crunch it out. So take this numerator off to the side and crunch it all out. And then, of course, you're going to divide it by 3. So, okay, I think we've done enough examples earlier. That numerator, if you wish to practice, when you do the integrate and evaluate, celebrate, graduate, compensate, is 158.25, and the denominator, of course, is 3, and then you divide that out, and it's 52.75. So yeah, there's a lot of work that happened up here. But, look at the previous examples, and I think it's fair for me to say, okay, go do that integrate, evaluate to that numerator. All right? So go practice that if you want. It's up to you. But that's how you find the average value of a function over a specific interval. Not a big deal. Okay.